Hello everyone, welcome to the webinar. Today's topic revolves around keeping people connected via Converged networks. Our speaker today is Benoit Fleury, who is the VP Product Line Management here at iBwave. He will take you through the key steps of designing a converged network and the key lesson learned from a recent carrier grade case study we did for a hotel in India. Benoit will also be presenting this talk in the upcoming Small Cells World Summit in London, so if you're there on day 2, be sure to check it out. Before we get started, I'll just go over a few housekeeping items. At any time during the webinar, you can type in your questions in the questions box, and we will answer as many as we can during the last few minutes of the webinar. You will also be receiving a video recording of the webinar shortly within this next few days. Also new this time, we're doing a couple of polls throughout the webinar. So whenever a poll question pops up, you could either type in the link that will appear on the slide or the link that I will shortly send out via the questions box. So you can just click directly on that link and answer the poll question. Now without further ado, I will ask Benoit to get us started.
Okay, thank you very much, Amna, and hello everyone. Thank you for joining us on this webinar. I hope you find the content interesting and enlightening. So what I'd like to do here is divide the discussion in 3 different sections. I'd like to start with some very basic market data just to set the perspective, if you will, for the rest of the webinar. And then I'd like to walk you through some let's say key steps and best practices around carrier grade design. So once we do that, then I'll move into the particular case study that Amna referred to, which is a hotel venue in India. So and then also I'll share with you the lessons learned from that case study. So moving right along, so I think we all know that most mobile data traffic originates indoors. So we've been hearing about this for a very long time, and so we've certainly witnessed this, and we all know it. But there are a couple of additional data points that I think are worth highlighting. So good points of interest. The first one is that there are 25% more connectivity issues that occur indoor than they do outdoor. So that's one data point. So that's maybe not too surprising for many of you. And the other one is that the indoor traffic is set to grow in 2020 by some 600%. So that's quite significant. And what that means, if you put those 2 things together, is that the indoor connectivity issues will significantly be amplified if they're not appropriately addressed right now. So, why is this important? Well, let's take a look at 2 enterprise verticals with respect to the importance of good indoor connectivity. And again, this will help set the context for the rest of the discussion. So the first is around the hospitality sector. So the great majority of customers, 86% of customers, will actually pay more for better experience with regards to indoor connectivity. And more than half, or 62, specifically 62%, will in fact switch carriers as a result of bad experience. So, so those numbers are quite telling. And let's take a look at another vertical, which is that of sports venues. So this is where we have a higher concentration of fans. And so actually this was done from a study that lasted 3 years, specifically from 2012 to 2015. And the first data point here is that there was a doubling increase in digital demand by the fans in that space of 3 years. So specifically, just some case in point, roughly half of the fans now share their experience via social media. And this is that was in 2015, and that was basically doubled from 2012. Another one is roughly 40% now get the details on the players and on the teams. and this is up from 20% in 2012. And roughly a quarter of the fans now receive in-game commentaries. So overall, 100% increase in digital demand in the past 3 years. So with that, if you look at the fact that 97% of fans nowadays bring a mobile device to the sports event, means that those numbers become really important. And still, a fair portion of those, so just roughly 40%, are still not satisfied with venue connectivity. So I think there's a great, these are great stats and great opportunities. So clearly, the conclusion here is that a dependable enterprise networks now have a much greater impact to the bottom line of the enterprise or the venue or for the specific owners. So that's important. And it goes without saying that a poorly planned network will cost a lot of time and money, not to mention high customer churn, which has a huge impact on the bottom line. So this is now essential to get things right the first time and not having to go back and endlessly tweak or redo parts of the network. All right, so this now leads me to the notion of carrier grade, because we hear about that a lot. And I thought we would just maybe take a little pause here and do a quick poll. And so what we're going to do here is you can access that link that you see there, pollev.com/IBW, or you can go into your question box, and you should be able to see the link right there, and just click on it, and then you're going to be able to answer the questions. So the question is, what is meant by carrier grade? And by the way, so click on your answer, and we'll start to see the answers coming in real time. So you'll be interested to see what the others on the webinar are seeing. So is it a service or a network which is strictly offered by a carrier? Is it one that simply never fails? Or 5 nines reliable? You may have heard that term before, 99.999% reliable. And or it's akin to a dial tone type of predictability. Is it something else entirely? Or you simply have no idea? So the results are coming in, and we're seeing well, a certain distribution, but clearly the 5 nines is scoring quite high. Never fails. We're seeing a little bit of everything. Mostly 99.999% reliable, or I have no idea, which is very valid too. So let's wait a few more seconds and see what we get. But it's pretty clear what the winner is here, and what most people associate carrier grade with. So I think that's that's quite correct. So I think this term has been around for quite a long time, and it is attributed to a very high degree of network availability or low unavailability, depending how you look at it, which I think translates over 5 minutes of outage a year or something like that. And so I think that's certainly the root behind carrier grade. And so if we move on, and so I think we'll stop the poll now, and it's pretty clear what people see. And really, I think in an enterprise context, so that answer, by the way, is correct in terms of the the definition of carrier grade. That's what is the most regularly used. And our view here in an enterprise context is that it's not too different to that of getting a dial tone very reliably each time you pick up a phone. And so the idea here is around the end user experience, to get a predictable and repeatable end user experience. And what's important is that in the context of a venue for like a wireless network, then it's important that that end user experience is predictable and repeatable no matter what the time of day is, or no matter where inside the venue, or no matter how many of the users they are potentially trying to access the same service as well. So, so it's good experience from the point of view of the user, and making sure that there's predictability and repeatability around it. So having said that, what are then, how do we achieve this predictability and repeatability? So there's key elements from a planning standpoint. There are three key elements in achieving this, and one is process. So clearly, I think if there's no process, then it's pretty clear there's not going to be a lot of repeatability, right, in how things are planned. So process is important. It doesn't need to be a heavyweight process, but it needs to be some process. Is better than no process at all. The next one is to have some tools which will ensure that there's some consistency in how things are done. So there's a whole variety of different types of tools here, but in a planning context, you could have good planning tools. And I think training is really important as well, because there might be a very good process, there might be very good tools, but if no training, then you're not going to get consistency in how the process and the tools are applied, and therefore you're not going to get good predictability of performance, and a lot of things might need to be redone, and we've seen a lot of that. So you can look at it a little bit like a three-legged tool, where if one of them is not too well addressed, you're not going to have a really good balance. So we believe that all three of those are important. And at this point, it's probably a good leeway into just saying a few words about iBwave before I move on with the rest of the discussion here. So I think for those of you not familiar with iBwave, or for those of you that are, but may use a refresh perspective on iBwave. So we've been around since 2003, so for 14 years now. We're headquartered out of Montreal. And so over the years now, we've pretty much become a worldwide standard for in-building network design and documentation. Today, our software is actively used by over 900 customers worldwide in more than 90 countries. When we started, it was really a single product that we had addressing really a single application with a single market. And that's evolved a lot over time. Today, we offer now a complete suite of solution where we enable all the phases of the deployment lifecycle. And also, we've introduced several years back a certification program, which is now very well established worldwide. In terms of innovation, we do continuous innovate. So we evolve our current products, so we broaden our portfolio as well. So just to put that in context for those of you that are familiar with our products, so we're continuously investing in iBwave Design, iBwave Mobile, Unity, iBwave Wi-Fi, which is a more recent line of product, and ICP, our certification program, which also continuously evolve as we evolve our products and our releases. And the reasons why we do this is largely to save time, to help you with your tasks, and stay current with technology. So we're continuously investing that way, but we're also broadening our portfolio to provide new solutions across the deployment lifecycle. And you're going to hear more about that in the short future. So that, I think, in a nutshell, gives a very high-level view of iBwave. And our planning and deployment solution set apply to really any technology or any architecture or venues, from a small office to a much more complex venue like a sports stadium, where it's a lot more complex because you have more complex surfaces and client surfaces and very high concentration of users as well. So from a capacity planning angle, it's a little bit more challenging. Subways and airports and the like. A lot of different types of technology. So whether we're talking about cellular, 3G, 4G, LTE advanced, Wi-Fi, public safety, etc. Now we're introducing new technologies as well. So multiple technologies, and importantly, multiple vendors as well. So we've got a parts database, which in fact is continuously being evolved pretty much every week. So we probably have over 25,000 parts in it from several hundred vendors as well. So we accommodate any vendors. And this is really important so that you can have ability to do a lot of iteration and do a lot of different scenarios in your designs and try to get some optimization. The other thing which is important as well is that we're considering all aspects of the network, so not just the RF, but we're looking at all the cabling, the components that make up the complete network. So probably that's enough said right now on iBwave. I just want to give a very broad perspective. So now what I'd like to do is talk a little bit about best practices from a carrier grade design standpoint. So if we look at the process standpoint on the three key elements that I mentioned before. So now I want to talk about the process phase, looking at the design. What are the key steps that are needed to ensure that you've got a good carrier grade design? So the first one is to understand what the end user experience needs to be. And from there, define what the KPIs are going to be. And this is usually important because this will have a direct impact on the rest of the design, whether or not it's compliant or not to those KPIs. And that should link as closely as possible to what the end user experience is going to be. And that has to take into account user density. So concentrations of users, you can have vastly different concentrations of users inside a venue, but also importantly, usage patterns. So what are the types of applications that are used, and what's the frequency of these application use, let's say within a time frame, within an hour. So that's one step. I think it's really important to get this right the first time, and you'd be surprised how difficult sometimes it is to get those requirements. The next one is with that information is to now consider all aspects of the network in the design phase. So looking, for example, at the structure of the building, this would typically be done in a survey stage, a pre-designed survey stage, a lot of these points. So look at the building structure, look at the building layout, how many floors, etc. The equipment room, where is it located? And where are the facilities? What are the logistics? So for example, the access to the equipment room may not be available all the time. So, so that needs to be taken into consideration for sure, because this will have real clear implications on the deployment phases. What's the existing environment? So this is really important. So typically a walk can be done here pre-designed to capture the RF environment, because this very likely will contribute to some interference that will reduce the signal-to-noise ratio and therefore data throughput and therefore end-user experience. So very important to do this properly, right, at the beginning, capture the existing RF environment. Backhaul considerations are very important. So the backhaul network, the backhaul capacity or the bandwidth which is available. So certainly when you start looking at capacity, this is that's an important element. And then there's all the RF work. So we want to make sure that it's a KPI-based RF design. So you're meeting the right KPIs. And here it's important to consider multiple technologies. So typically users will have, so nowadays users are, almost everybody on their device, they have both Wi-Fi and LTE or some cellular technology. And so, so it's important to consider all of these technologies in the design. And then cabling is really important. So capturing the cabling run, where does the cabling need to be? And a lot of that information also can be captured at the time of survey so that you know where to run or where not to run cables. And so cabling running is important. Where is the active equipment and what it is, and what are all the capacitive components, and where are all these placed on the venue, ideally in a 3D floor plan. So lots of things to consider in the design, not just the RF, but all aspects of the network and all technologies as well. So that's the next phase, which is the design phase. And then there's going to be some iteration that typically needs to happen. So the idea here is to optimize the design while meeting those KPIs that were established from the get-go. And this is where we exercise trade-offs between cost, performance, and future-proofing. So future-proofing of the network is important because, especially in some venues, and we're going to see an example of that later on, where it's really tough to get access to do work. So you don't want to go back 6 months later and have to, because you forgot to add something or because you need to, add a new band or technology, because that can be quite expensive. But it's part of the trade-offs, or how much future-proofing you do, and I'm going to talk a bit about more about that later on. But trade-offs between cost, performance, and future-proofing, important. Keep meeting those KPIs. And you can look at different parts. You can look at different vendors, and even in some cases, different architectures, right? So you're going to get the same end results, but different ways to optimize your performance and your cost. So some iteration there. And then the last step, which is certainly not least, is to document all of that. So document what was captured in the survey, document the design, store it somewhere, ideally some central place, not on your individual laptop, so that it can be accessed for the next steps. And this is going to ensure that the subsequent steps in the process are going to be done effectively. And it's important not just to store the information, but it's going to be accessible to different stakeholders. Otherwise, we're defeating the purpose here. So just some examples for installation. I talked about cabling run before. That's important. Annotations is really important. So here you can take pictures of different places where you may or may not can run cables or place an antenna or a small cell. And that's going to be really useful for the installation phase. And maintenance is critical, because maintenance, in fact, is it's probably the longest period in the overall life cycle of the project. So you want to make sure that there's a good reference point as to what's being deployed where. So if later on you need to do some troubleshooting or you need to do some upgrades, then you've got a good reference points. So those, I'd say, are some of the key steps that need to be taken into account for a proper carrier grade design, so that you can ensure you get repeatability and a good predictability of the end user experience. But it starts with defining the right KPIs at the very beginning. So that leads me now to another poll. So just curious to hear your views on that. So you can just refresh the link, or I think if it's open, you'll see the new question anyway. And here, I'm curious to know, what design KPIs do you mostly use? And so you get just click on your answer, so we'll see in real time what the people are mostly using. So there's signal strength or coverage per area. For example, so many dBms. You want to make sure that you reach at least so many dBms per, let's say, 95% of square footage. So this can be RSSI, RSCP, or RSRP, depending on the technology. Signal to noise and interference ratio per area. Then you've got peak data throughput. You got average data throughput. Something else entirely that you're using, or you really honestly have no idea. So that's a good answer too. I'm just curious to know what most of you are using. So far it's signal strength and coverage per area. And the signal to noise is also a second, maybe not a close second, but a strong second. And yeah, average data throughput, just a tiny little bit. So that's interesting. And good. So we don't have something else entirely, so at least we've captured most of the KPIs that people use. We can probably move on now. And I think it's pretty clear what most people are using. So, all right, now let's take a look at KPI examples that will help us better predict the end user experience. Yep, we've got a resurgence of average data throughput up a little bit, but we'll move on now. So thanks for your answers. And by the way, I think we're going to capture all of those. So when we send you the information, you're going to see those results. All right, so predicting end user experience. So let's look at signal strength KPI. So this could be RSSI or other measures that are indicative of signal strength. And so here's an example of a venue. So this is 3D modeling of a venue. I think this is a hotel. And so yeah, so we see different floors. We see some small cells or antennas, some cabling, and there's a legend which is just about impossible to read. And in fact, what the legend is an RSSI legend, and you can see the tiny little writing on the bottom, which is in red, because it means that KPI has not been met. And I think that particular KPI was minus 75 dBm on 95% of the square footage or the area. So in that particular case, it's in red because that signal strength is not met on that. For that area, it's met for about 84% of the area, so that's why it's red. But it's really hard to see the color because it's super small. And I think that's what's mostly used. Frankly, signal strength is what's mostly used. It is important because it's a good indication of the strength of the signal, but it's not too relevant to the end user experience because there's a lot of other factors that need to come into play. So if we look at a different KPI now, if we look at average data throughput, so this is the same venue, just a different output map. In this case, it's average data throughput, and what you see here is different average data throughput per user in different sections of the venue, because well, yeah, you're going to get different signal, you're going to get different levels of interference, but importantly, you're going to get a different concentration of users, which is going to have an impact on the average data throughput per user. And so in this particular case, over the whole venue, the whole area, it's an average of 32.6 megabits per second. And so in some places, the average data throughput is going to be higher. Other places, it's going to be lower. But the average of all that floor, that's what the number is. And there could be different ways to slice this. There can be different ways to measure the average data throughput in terms of a KPI. It could be, for example, I don't know, make sure that the average data throughput is at least 10 megabits per second, everywhere. Or maybe 20 megabits per second on at least 90% of the square footage area, or overall across the floor. So I think there's different ways to do it, but here you've got something that takes into account signal strength. It takes into account interference and therefore signal to noise and interference ratio, and it also takes into account the capacity angle as well. So that's why this one is a little bit more difficult to get to, but it's going to be a more direct link to the end user experience in terms of what kinds of applications can they use, and it also takes into account how many users there are in the same area accessing the same radio. So yeah, so that's what I want to say here. And you may or may not be aware that iBwave recently revamped its capacity planning engine, specifically in Release 8, which was released last fall. And actually, we've been working quite hard on that to turn that around. And what we had before was a capacity engine that was a lot more voice-centric, and it was based on Erlang calculations. And we're moving here to a much more data-centric mechanism, which is a lot more closely tied to the end user experience. So so we look here at user density. So for example, the number of users on the floor, or the number of users per zone, because you may have some high density zones inside the venue. So for example, cafeteria in an office, or a conference room in a hotel. So these will have different concentrations of users. And also importantly, for each of those, look at the usage patterns. So, or the usage profiles. What kind of applications are being used, and yeah, with what kind of frequency per hour or whatever. So this takes a look at the dynamics of usage profile and user concentration. And in some large venues, well, you typically have multiple operators, and so here you can take into account the different splits or market splits between operators. So you can see an example here in that little window of a couple of operators, and then you also have technology split. So in this case, HSPA for you know, in this example, with the first operator is 20%, and 80% is LTE. But you can also have a split with Wi-Fi technology as well, so you can have different splits. And you can also enable or not voice over LTE or voice over Wi-Fi on a per operator basis, because different operators may have different schemes. So this will all have an impact on how the capacity is calculated. And then there are output maps that are now capacity related. So the first one, it's a capacity output map. So then you see if you pass or you don't pass, looking at different parameters. And so you might have some regions of the venue which will pass and other regions which will not pass. Therefore, the overall venue will probably not pass. And so this is good to keep track of compliancy, right? Capacity based. And average data is the other one that I described a little bit on the previous chart when we talked about KPIs. So here you see different average data throughput in different areas of the venue. And for those of you familiar with the products, this capacity planning is it's really particularly useful for for Wi-Fi and small cell-based networks that tend to be highly capacity limited from the point of view of the design process. So therefore, so these tools are available both in iBwave Design, which is a desktop tool, and iBwave Mobile Planner specifically, where you can design on-site Wi-Fi and or small cell based network. So you've got some capacity. Maybe not as extensive as what's available in the desktop tool, but there's some pretty easy to use capacity planning is there as well. So that just in a nutshell, I just want to share with you what was recently done in terms of capacity planning. But the important thing is that we're now tying this a lot closer to the end user experience. All right, so now we're probably good to move to the case study and share with you some of the lessons learned from there. All right, so what we're talking about here is a five-star business hotel complex in India, which is not a new hotel. It's already an existing hotel. So that's part of the challenge right there, right? So it's not a greenfield design. We need to take into account something that already exists, and there was a network there before, but it was really not performing, and there was a lot of dissatisfaction. So the total area is approximately 600,000 square feet, spread over 14 floors, and the total number of rooms is 437, and that includes well, the floors include 2 basements, and the rooms also include several conference rooms as well. So this will obviously have different user concentrations in there, but it's just a total number of rooms. In terms of the number of users, that ranges from 1,500 to a peak of 4,000 users, depending obviously on what event is happening on that particular day. And because it's already a fully operational 5-star hotel, then there's a limited number time of access per day. So in this particular case, there was only 3 hours allowed to do work on the network, right? So that obviously has implication in the deployment phase. All right, so that's the high-level parameters of the venue. Now, if we look at the requirements, in terms of technologies, we're dealing with 2 technologies: LTE in the 2.3 gigahertz band, and Wi-Fi in both the 2.5 and a 5 gig bands. So here we're really talking about a HETNET network or a converged network, and because we have multiple technologies, but we're planning them as a holistic network. So that's for the technologies. In terms of the KPIs that were required, data throughput, 3 megabits per second per user, period. That's what we need to have everywhere. And then there are also some signal strength KPIs. So for LTE, neg 98 dBms RSRP over at least 95% of the area, and for Wi-Fi, neg 65 or neg 70 dBm, depending which band, on at least 95% of the square feet or the area. So those are the key KPIs that were given at the start and what the team worked with. All right, so now more requirements, but this time in terms of capacity requirements. So some of that I've mentioned before, but there's a little bit more information here. So peak number of users, now this includes guests and staff, 4,000. Required throughput, we talked about that already, 3 megabits per second. And concurrent users, so this is an important number. So here we're assuming that we're going to have a maximum of 2,000 concurrent users. And, you know, across both technologies. And there are some high density zones that need to be considered in the design. So there's a lobby, obviously, and there's conference rooms, and probably the restaurant as well. Will tend to have a higher density of users. Technology split, which is assumed here, is 60% LTE and 40% Wi-Fi. And we have different cell load assumptions for LTE 50% and Wi-Fi airtime usage, which have an impact on the design and on the capacity planning for sure. All right, so those that pretty much sums up at a high level the key requirements that we're working with. So now, what methodology was used in the overall deployment? So what was used to plan, to design, and to deploy that network? So we have a number of steps, and I'll just walk briefly through each of those. But what you can see here is that we're addressing the whole deployment lifecycle, not just a slice of it, from pre-sales all the way down to the maintenance phase. And in fact, iBwave enables each of those phases to be very effectively tied together so that you've got a really nicely integrated workflow from A to Z. And by the way, this allowed a lot of scaling here. We're talking about one specific venue, but there were in fact thousands of venues that have been designed in the past few years. And so I think it's important to have this workflow really well established. And so that ties down to what I was talking about before when I talked about process, tools, and training. So all of those need to come together to be able to get the level of scale that was achieved. So the first phase is the business case phase. Sometimes it can be seen as a pre-sales quoting phase as well. So here the idea is to capture the client information and determine the business case for the venue. And in this particular case, there was an internal tool for which, through an API, we connected iBwave Unity, which is our storage and collaboration platform. The idea is to capture the information from the very, very beginning, because that same information is going to be used throughout all the steps in the deployment lifecycle. The next phase after that is to do a survey. So this is done on-site. It's done in all cases by a field technician, and it's done using iBwave Mobile Planner, which is an Android-based app that runs on Android tablets. And so what's done here is two things. There's a survey which is done. So this is capturing all the information about the venue, a lot of picture annotations that are geolocated on the floor plan, so you know exactly what to watch out where, and a lot of notes are taken here. And there's also importantly a preliminary design. So this is small cell and Wi-Fi, and so that can be designed from the tablet by the same person while on site. So that's what was done here. So survey and preliminary design using iBwave Mobile by a field tech. The next phase then is to do a design. So this is done by an RF designer using iBwave Design at a different location, and this is where the design was validated and some optimization may have been done, and but also finalizing all the reporting, because there's a fair bit of documentation that was done for the venue. So this is done out of iBwave Design. Then the next phase is the build phase. So installation is a key element here, and with the collaboration platform, with iBwave Unity, the technician or the installation person in that case can download the completed design on mobile and do as-built documentation as build changes. And this is re-uploaded back onto Unity, and that can be then used later on for referencing to do more work. And then all of that information is captured in iBwave Unity, and it's then accessible by maintenance personnel to do either troubleshooting and or upgrades down the line. So this is the overall workflow. What we're focusing on here a little bit more with this case study is on the survey and design portion. The network is just now operational, so it's early into the maintenance phase, and so this is, if you will, an evolving case study as it goes. But we're focusing a little bit more on the survey and the design phase. So yeah, so what I'd like to do now is take you to another poll, because now I'm curious, based on everything that I've mentioned before, in terms of the requirements and what is being looked for. How many radios do you think are required for this hotel project? So, so this is a multiple choice question, and you have a handful of different potential answers. Curious to see what you think, how many radios are needed. So less than 100, 1 to 200, 2 to 3, 3 to 400, more than 400, or you truly honestly have no idea, which is perfectly valid as well. So far we've got, yep, pretty good distribution up to 300. Some of you have no idea. I think it's very appropriate because there are a lot of variables, and you may not have all the variables, so that's a very fair answer. But so far, most of you feel it's up to about 300. A few of you think it's a little bit more than that. Certainly no more than 400. And how are we doing with time? Another couple of seconds. Doing okay? All right. So most of you feel that it's less than 100 radios are needed. Okay, this is really interesting. And 1 to 200. All right. So very few believe it should be between 300 and 400, and no one thinks it should be 400. Okay, good. This is great. So what's the answer? All right. So so here's the answer. In this particular design, 390 radios were in fact needed, and this is, I think, a lot more than what most of you feel is needed. And so it's not too surprising here, but what was considered into that is there's a few things that needed to be accounted for. First of all, this is not a brand new hotel. There's a lot of walls, a lot of very thick walls, which do have an impact on the propagation. You also have a peak number of users, but we also want to make sure that we design for worst case propagation. And in this case, worst case propagation is using 5 gigahertz Wi-Fi. So, and increasingly over time, more and more people are starting to use that band, and we want to make sure that there's some level of future-proofing in that design as well, because it's particularly painful to go back and to do some changes. So we want to make sure that there's enough wiggle room here to accommodate worst-case scenarios in terms of band and propagation. So yeah, so almost 400 radios were needed in total. But there's a lot more than radios. We also have networking equipment. So in this particular design, we had 59 networking equipment, a combination of controllers and layer 2 switches. We had a lot of miscellaneous parts, maybe almost 2,000. So here you have cables, you have connectors, you have trace panels, cabinets, mounting kits. So all of those are considered in the design. Not just the access points or the small cells, but all aspects of the design. And when we run an equipment list or BOM list, a bill of material report, we want to make sure that we capture all the bits and pieces that are needed. So 1,700 miscellaneous parts. And in terms of cabling, a total of 17 kilometers of cabling. There's actually more in terms of individual cables, but because there's cables that are used for power and others. So, but in terms of overall cabling, when you bundle these together, it's a total of 17 kilometers. So quite a lot, and quite a lot of reports as well were generated. And in this, it was certainly the case for this design and this venue, but it's the case for every other venue that was designed as well as part of this project. So a total of 7 reports, an equipment list, different output maps. I've got a couple of examples later on. And cable routing report, cost, annotation, a compliancy report, and a capacity report as well. So those were the high-level results of this design. And then we've got a few report examples. So just in the interest of time, I won't spend too much time on those. So there's a cable routing report. So this, you'll have the cable IDs, where they originate and so on. You have a compliancy report. So this will be done, you know, for different technologies, for example. So you see what the KPI was, what was the actual result, and whether or not it's compliant. So in this case, it's yes, 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 or compliant. And different output maps. So there's just a couple of examples here. So there's a SINAR output map. There's a capacity map as well. There's a CCI map for Wi-Fi, so co-channel interference. So number of maps or output maps. And so yeah, those are the highlights. So here are some of the lessons learned from that case study. The first is that it took 3 days to do that. The survey and design part, right, from beginning to end, and with one visit. And so typically this would take, you know, with conventional approaches, this would take 10 days easily. With 3, maybe even 4 visits, depending. So there's sometimes a lot of back and forth. When things are not quite done right the first time, you got to go back for more. So yeah, we're talking about 70% quicker, certainly in time, but probably even more in savings when you consider the personnel that was used. And I think the notion of process with an integrated workflow really helped into that. The tools is very important because here you had a common set of tools, and there's also a collaboration tool to ensure that the proper information can be exchanged between the different groups, the different people that are involved in the project. And training was also done. That is important as well for the reason that I mentioned earlier. So I think if you take those three key elements, you do those well, then you're going to be able to do that fairly quickly, and importantly, you can scale as well. So you can do it for a lot of venues, and a lot of them were in fact done in parallel at the same time across the country. So yeah, that's one lesson. The other one is that the deployment was really challenging because since it was a hotel that was already fully operational, and so very strict availability of access per day. So in this case, it was 3 hours per day. So what that means is that if it'll take you, so many days to do the deployment, we'll multiply this by 8, and that's what happened here. So that points to the importance of doing a proper survey and a proper design and getting it done right. Because if you don't do that, just the time it's going to take and the cost is going to be multiplied if you have to go back and do more work. So I think that's an important learning. And the next one is, well, we're talking about a heterogeneous network here. We're talking about two technologies that are typically done differently, but this was all done together. And that helped get a quicker deployment overall, because not only was the planning done in one go, but the documentation is all the same. The equipment, in this case, was all the same. The cabling and all the power infrastructure, it was all common. So I think that contributed to a lot quicker deployment. And here it takes a lot more time to deploy it than to actually survey and design it, just because of the factor that I mentioned before. So by being able to do these technologies together, overall, you get a lot of benefits. And the fourth one is future-proofing, which I think is really important and should not be underestimated, especially given this type of venue. It's particularly important. So any upgrades are going to be costly, for sure. So I think it's important to plan for worst-case propagation, which is what was done here for 5 gig Wi-Fi. And as I said before, more and more people are moving to that. And also, even beyond that, so if we look at LTE-U, so in the case of India, the band here is, I believe, 5.8 gigahertz. And so this design will be able to accommodate that as well. So there's some future-proofing even in terms of technology in the design. So you might be able to do a very limited amount of tweaks to be able to get what's needed without having to go back in the venue and redo things. And I think that documentation is an important component of future-proofing a network, because here we have something which is centrally stored as built, so it's as built documentation that ensures that you're going to have a proper reference for future work that may need to be done. And this will certainly contribute to future-proofing your design, just by having good documentation, which is stored in a smart manner and importantly accessible to the other stakeholders down the chain. Okay, so now time for one more poll, and this is the last, I promise. And so the question here is, for you, what aspects of carrier grade is the most challenging to you? And I'm really curious to hear your views on that, because that really does vary a lot. Is it to capture the right requirements and KPIs in the first place? And you'd be surprised sometimes, or maybe not, in terms of how difficult it might be to get those right requirements, especially when you're dealing with enterprises and you're dealing with venue owners. And I had a user group about a month ago or so in New York, and yeah, somebody mentioned that one of the venue owners was specifying that 3 bars on the phone is the requirement, and so this is probably as vague as it gets, and that can almost guarantee that you're going to have a lousy end user experience at the end of the day. So I think getting that information right can be challenging. modeling the venue can be really challenging as well. It can take a lot of time, especially to really do it well. And it's important that the venue is modeled very well, because if it's not, even with some small mistakes, we have a blog on that. You can look at it on our website, really good examples of that. A venue which is not properly modeled, when you scale things up, that things will really amplify, and you're going to end up with a design that's either going to cost too much or cost too little compared to what it should cost to be able to get the right performance. So modeling the venue is a challenge. Creating an optimal design is always a juggling act between balancing cost, performance, and future-proofing. How much do you future-proof? Clearly, it's a question of degree. So that's a delicate balance. Generating the proper documentation can sometimes take a lot of time. Accessing the right information can take a lot of time as well. Or is it something else entirely? And I'm happy to see so far I think we've captured all the 4 key challenges. We're not missing anyone. Otherwise, someone would have voted for something else. But yes, I think creating an optimal design is clearly seems to be a #1 challenge, followed by modeling the venue and then getting the right requirements and KPIs. So thanks very much for those views. That's very useful. So yeah, we can probably summarize now, and then we can take some questions. So, all right, so we showed that good indoor connectivity is now a lot more tied to the bottom line of different types of enterprises. So for example, guests or fan loyalty is now directly impacted. And so you want to make sure that you start with a good understanding of the KPIs or the end user experience, and then define the KPIs based on that. And so that's going to be the first step. Then the next, we need to plan, design, and deploy a network so that the defined end user experience is predictable and it's repeatable. And so for that, we got to make sure we got the right process, tools, and training in place to do so. And then we focused after that a little bit more on the survey and design portions. And so now we're going to do a design which is really KPI based, but that are KPIs that are as much as possible tied to the end user experience. So here, first of all, we need to take into account multiple technologies, because majority of users now are dealing with multiple technologies. So that needs to be taken care of in a holistic manner, and in capacity as well. So you have to look into capacity planning to be able to ensure that you've got the right end user experience, especially when you're dealing with the average data throughput. So that's really key. And then last but not least is to make sure that you've got centrally accessible documentation, ideally as-built documentation that can then be accessed by other people at later points in time to be able to do whether it's installation or troubleshooting or upgrades or whatever the case may be. All right, so I think that kind of sums up the flow and the key messages in the presentation. And now with 5 or so minutes left, we can take some questions. So Amna, back to you.
Thank you, Benoit. So we do have some questions. Just to the listeners, if you have any more questions, you can just type them in the questions box, and we'll try to get to them. So the first question is, how were the issues faced addressed in the design, especially from a channel utilization perspective in the case study?
Okay, so well, first of all, maybe if I look at, because we have 2 different technologies here, so I'm not sure I'm addressing the question, but if you look at LTE, so first of all, LTE is it's obviously licensed, so the bands are well controlled by operator. But then it's important to do the RF. I mentioned that before, to do an RF walk to really understand what the RF environment is, because different carriers will have different approaches, right? Some might use different bands for the micro network, and for the indoor network, some might use the same band. In the latter case, then I think interference is particularly important. So you'll make sure that you do a walk. Let's say typically that's done around the boundaries, and then you take that into account for the design. Wi-Fi, then you've got to deal with different dynamic here. So you have different channels, and we have automatic channel assignment. So that we can optimize channel utilization. And in this particular case, the not too many challenges around channel utilization in the rooms, in the hotel rooms, right? Because you don't have too many users there. But certainly in the denser venues like the conference rooms and the like, here the channel assignment, it was optimized really according to the peak users. So in the end, there's minimal conflict.
Thank you, Benoit. So here's another question. What is the difference between Wi-Fi network planning for the iBwave Wi-Fi only and Wi-Fi mobile tools?
Well, first of all, the mobile Wi-Fi. So there's iBwave mobile, the iBwave Wi-Fi, and iBwave Wi-Fi mobile. So the iBwave Wi-Fi is on the PC device, and so you can both do a design, and obviously with mobile you can also do additional site survey work, but and you can do design, but there's obviously a lot more capability into the PC product, because this is you can do much more detailed capacity planning. You can do a much more detailed modeling of the venue. The propagation is a bit more accurate because we use fast ray tracing. We use a different algorithm on the tablets, and so with fast ray tracing, you model everything and you get a bit more accuracy. You can do 3D modeling. You can do inclined surfaces for complex venues like stadiums. So you can do at the high level the same functionality, but with more resolution, more precision with the tool. But they speak the same language, and you can exchange files from one to the other. So you can start with one, as we've seen in this particular case study. You start with mobile, and you do most of the work, and you can do the final touches on the PC, and then do the final reports. So I think those are some of the differences. And by the way, it's the same for small cells as well, so not just Wi-Fi. So in the small cells, it's a mobile planner in this case, and you can also create a small cell design also with a faster algorithm, which is better suited for tablet, and so same kind of differences there as well.
Thank you. Let's just do one more question. How do you cover off different specs and requirements from different carriers in the same one network and avoiding interference?
Well, first of all, you have because it's a licensed technology, so everything is very controlled, right, in terms of which operators is working with which band. So I think right there that's being addressed. But importantly, as I mentioned before, you want to be able to account for interference. So it's important to do RF walk at the beginning and make sure that's taken into account into the design. And so yeah, that's how this is addressed. And for Wi-Fi, it's a different dynamics here. You've got some overlapping channels, especially in the 2.5 gig. You have non-overlapping channels in the 5 gig. So you have but then you have the automatic channel assignment as well. And then you also have to look at airtime utilization and take that into account in the capacity calculation, so that you minimize conflict and you can maximize your capacity that way.
Okay, thank you, Benoit. So I think we can wrap up now. Thank you for your questions, and I would like to thank everyone for attending. And just a quick reminder that the recording will be available within the next few days, so you can look out for that in your inboxes. And once again, thank you for attending, and have a great day.
Thank you.